Next we have the structure. So what is a structure? A structure is a composite data type, and it can be used to group list of variables under the one memory location. That means, suppose over here what we have done, we have made in a as an integer. But what if I want to have multiple number? I want to have a set of integer, float, character, everything under one. In that case, structure is useful. Now, structure is represented this way. We use the word struct in order to make our the programming language understand that I'm writing a structure. Then we will give a variable name to it. Now inside that we can have different types of data. We can have data of either integer, we can have float, we can have character, different types. So it will be better if you see an example. As in this example, you can see that I have the made a structure of employee. The employee is a variable name, struct is struct. Over here I have integer as his ID, float as his salary, int as a mobile number. So now once I have defined this structure, once I have defined it, I can reuse it again and again. As you can see over here, I am using this structure for 3 times: E1, E2, E2. So E1 is the first employee, E2 is the second employee, E3 is the third employee. I do not have to rewrite all this again and again. So structure is helpful in this way. You can go through this code. I have already written the code. I will provide you with the code, or you can write it yourself. You find it in the PDF also. Structure. So this is the code. Okay, I need to turn off my antivirus, or else it might create some problem. So see, I have created. So he's asking me for an ID. So let me give him the ID. Let me give him salary as 111.1 and mobile number as 1212. So second salary, let him be 222.2, then 2323. Then the third ID is 2.33434. That's it. See, the data has been entered. So I can use it again and again. I can have another ID as E4, E5, E6, E7. So I can have as many as I want. You can either use code block, or you can use any online compiler, or you can use whatever you have. It doesn't matter. So if you use the online this compiler, in that case you will type this. Doesn't matter. Now what is an array? Array are defined as a collection of similar types of data items that are stored in a continuous memory location. So in array, the similar type of data are stored in continuous memory location. Each of them will have the same data types and carry the same size. Example, if I use integer, it will have 4 bytes. Now arrays are used to store data in a continuous memory location, where the first element is stored at the smallest memory location, and consequently they are stored in a continuous manner. Now the elements can be accessed randomly, so that is not a problem, since we can calculate the address of each element of the array with the help of the given base, isn't it? So in C language, the syntax for declaring an array is this: int arr10. So what I'm telling him that this arr10, it can have an integer. Over here I'm telling him arr10 can have a character. Here I'm saying it can have a float. So what is the need of array? See, in most of the cases, we require to store a large number of data of similar type. Now we can have as many variable name as possible, but having too many variable name creates a difficulty of remembering the variables. So in order to solve that problem, it is better to define an array. So if we have a large number of data which are of same type, then we can club them together in a single array. In that case, it will be helpful. We do not have to write multiple number of variable names. If it is a two-dimensional array, then it will be in this manner. So it will have two values. A0001 is the first value, A01 is the second value. So there will be two values. They are represented in this way: maximum number of rows and maximum number of columns. Similar to the 1D array, a 2D array also can be accessed randomly. So it's No, it is not a problem. I have written a code also over here. If you can go through it, we'll find that what I have done. See, if I have a two-dimensional array, so obviously it will have two parameters because I have two location, two, isn't it? I have this axis, I have this axis, so there are two axes available. Hence, there are two types of data are required. So this is the first loop, this is the outer loop, this is the inner loop. So this inner loop will keep on going in the initial stage when I is equals to 0. In the initial stage I is equals to 0, then my j is start till 0, then it will be 0 0, then j will go to 1 0 1, then j will go to 2, then 0 2, this way it will move on. In this I am telling that my integer is having a 3 by 3 matrix, and hence my outer loop starts on 0 and ends at 3 j. So I am in this step I am scanning the data. Once I have scanned the data, I am going to print the data in this. So this is the code, this is the code for selecting. Next we will see what is linked list. The next topic is the linked list. So what is a linked list? A linked list can be defined as a collection of objects called nodes that can that are used to store our data. Now they can store the data in a random manner in the memory and are interlinked with each other. What do I say is, what do I mean by node is that the node will have two fields. As you can see over here, the node has two fields. This is one field, this is the another field. One field is used to store the data. As you can see here, I'm storing the data. This is the data storing element, and the next is your it is used to store the address of the next node. So these are basically single nodes. As you can see, these are single nodes that are having two paths. One part is used to store the data, another part is used to store the address of the next node. Hence, you do not have to store the data in a continuous manner. The last node of the list contains pointer to a null, because obviously the last node will not have anything else to point out, so it will store null. The list is not required to be in continuous manner. Why? Because this consists of nodes, and the nodes will have the address of the next node. Suppose this node 1 will have the address of the next node 2. Hence they do not need to be continuous, and the node can reside anywhere in the memory. So what happens is that with the help of this we can optimize the space requirements. Initially, for other types of method, what we have to do is that we have to initially tell him how much space is required. Suppose I define my array having a size 100, but I'm not going to use 100. I might use only 50 out of the 100. So the rest 50 is blocked because I have already initialized it and my program has fixed that 100 space. But in linked list, that problem is minimized. So the list size is limited to the memory size and does not need to be declared in advance. That is the biggest advantage. Now empty node cannot be present in the linked list, obviously, because if a node is having a data, it will have some address associated with the data. This address is the address of the next node. If it does not have any address of the next node, that means it is the last data and hence it is a null. So there cannot be any empty node in the linked list. Now, as I have told you, what is the difference between linked list and array? In array, the size of the array must be known in advance. Increasing the size of the array is a time-taking process, and to be honest, it is sometimes impossible to do it during the runtime. Runtime means when the program runs. Moreover, in array, it has to be continuously stored. The data, the memory has to be in a continuous manner. And hence inserting any element to the array needs shifting of all the predecessors. But these problems are eliminated in the linked list, because in linked list allocation of the memory is dynamic. All the nodes are done in a non-continuous manner. So all you have to do is that you have to determine your first node. The first node will link to the next node. It can be anywhere in the memory space. Okay, na? And your list will grow as per the program demand. So depending upon your program, it will grow. So these are the advantages of linked list. So if a question comes, what are the advantages of linked list with respect to array, then these are the points which you can mention. Now, as per your syllabus, you will be taught single linked list, double linked list. So let's see what is a single linked list. It is defined as a collection of ordered set of elements. So what do I mean by that? It's a one-way chain, or a single linked list can be traversed only in one direction. So in a single linked list, it will be traversed in only one direction. As you can see over here, head is the initial point. Head is a pointer. It is a pointer. It is a pointer that will have the value of my first node. This node will have the value of the next node. This second node will have the value of the next node. Since this is the last node, so hence we have a null over here. Now this can be traversed in only one direction. Now this 90, this node does not have a data of this. Hence it is singly linked list, because it is traversing only in one direction. It contains pointer only the next pointer, therefore it cannot traverse the reverse direction. As I have told you, the last node of the list is identified as a null pointer, as you can see over here. Now, what are the operations that can be performed in singly linked list? Anything starting from insertion at the beginning, insertion at the end. There is no problem in linked list. Why? Because as I have told you, all you need is the address. The address will be mentioned over here. It can locate to the next data, isn't it? So we can insert it before this, or we can insert it after this. It will not be a problem. Insertion at a specific node, deleting at the beginning, deletion at the end of the node, deletion after a specific node, traversing means traveling through the node and seeing, printing out the data to finding, searching, we can use searching operation. So these things we can do. Now, as I have told you, you have to create node programmatically. You have to create this node you have to create programmatically. So how to do so? This is the standard way of creating node. What is a node? As I told you, the node will have two elements. One, it will have a data. Next, it will have a pointer, means it will have the address of the next node. Hence, we will write it is a structure. I've already told you structure can have multiple types of data types within it. So I'm writing struct node over here. I'm telling my data is a integer data. It can be float data, it can be character data, does not matter. You will mention it before that. And it will have a struct. Pointer means it is a special type of, this pointer standing means it's a pointer. Pointer can store our address of the next node. What is this malloc? Malloc basically tells it's a dynamic allocation. It's a way of dynamically allocating the nodes. Size of gives you the size of the node, because initially we do not know what is the size of the node. So size of will give the size of the node, and malloc will allocate it depending upon the nature requirement. So it will dynamically allocate. So in this way you can define your structure. As you can see over here, this is a structure node. This is integer. This will have the two parts. The first part is having my data. The second one is having my index is 2, and I have defined my pointer. This is a program. You can copy this program, and so you can copy this program. I will also give you the text version of the code. So just copy it. You can copy this entire code, and you can later on see. Let me briefly tell you about this code. Now all the operations that can be possible has been mentioned over here. Now here I have initialized my node. My node will have a starting address, isn't it? So this is the starting address. These are the operations that can be done with this program. Insertion at the beginning, insertion at the last, random insertion, delete, last delete, random display. These things can be done. Search. Void main means the starting of the program. So initially it will ask a choice. It will give us the choice. Here I have given 9 choices. As you can see, there are 9 choices which has been given. Open. Yeah, this is the program. Let me turn off the antivirus, or else it might create a problem while running it. run. See, when you run this code, this particular code which is present in the manual, you will be asked to enter a choice. Suppose what is the first choice? First choice is insertion at the beginning, so I will give first choice. Then I will have to give him some value. Let me give him the value with that. Next, I'm asked. I want to add at the beginning again. Then I need to. I want to see what are the elements. So it's 8. So see, by 8 I just given me the 2 elements. So just go through this code and you will understand it. Depending upon our choice, see, it was asking me my choices, isn't it? So depending upon my choice, it will scan my choice, and depending upon that choice, whether I have given 1, 2, 3, 4, 5, it will switch. It will switch to that particular code. If I write 1 as I have written over here, it will go to this code. When I wanted to show, I wrote 8, isn't it? So it will go to this case, display. Now this this is the basic code which this is a subcode which have been defined, isn't it? Void beginning insertion at the initial. So when you want to add any data to the node, first you have to determine whether it is possible to add or not. I mean, initially as a programmer, I'm not sure whether there is memory available or not. So that is the reason you need to first verify whether it is possible or not to add the data. So if it is not, then you will say there is overflow. If not, then we will take the data and see the item. Suppose I have scanned with this. I have scanned the item. Item means the value which I wanted to add. And where do I have put it? My pointer is pointing to the data. Now here you must understand one thing. Your node is having two elements, isn't it? This is address. This is address. Address means the address of means the location of the next node, and this is the data. This is the data. This red part. This is the data. So your pointer, your PTR pointer is pointing to your data, and it is putting the value over here. Next, the head means the first initial value. You're putting it in the next in the address location, putting into the address location. Hence, we write in this manner. Then we update our pointer and we go. Similarly, if you want to insert at the last, again you have to see whether it is possible or not to insert. We will see it. If it is possible, then the element, the data which we want to put, we'll put the data on our data portion, and we will update our last node, because you remember the last node in our linked list has to be the last node in our linked list will have null over here, and hence I am putting null in my last node. Why? Because this code will insert at the last. Similarly, if you go through the other program also, you will understand it. If you face any problem, do message me in my WhatsApp number. So there's a very big program. You can copy it from here, or you can write it yourself. You can write it in C, C++, Java, Python, any language. I am comfortable with C, so I will write it in C. Now, what is a W linked list? Now, W linked list, in the W linked list, it will not only have the value. Suppose it will have three parts. In the middle portion will have the data. This will have the data. This portion will have the location of the previous node, and this portion will have the next node. So in the W linked list, it consists of three parts. As you can see, this is the data part. This will have the previous node information. This will have the next node information, and hence W linked list, it can move in both ways, in the forward and the backward both ways. As you can see, this is the first node. This first node is having the header is pointing to the first node. Then this has the location of the next one also, and this will have the address of this one. Similarly, this will have the address of this one, and this will have the address of this one. So they are interrelated with each other, the double linked list. Similar to the single linked list, double linked list will now have a extra node, one point as extra pointer. This is the previous pointer, this is the next pointer. In single linked list, we had only this data and this one, but in double linked list, we also have the previous one. In single linked list, we can only traverse in one direction, but in double linked list, we can traverse in both directions. Now, generally, double linked list consumes more space for every node, obviously, because it will also have the information of the last. But it's better in this way because we can then manipulate the data in both way. As you can see over here, this is the first header. It is having the data of this. Previous means what is the previous value? Previous value is over here. What is the next value? Next value is 4. Where is 4? Here is 4. Now this 4 will have the previous value of 1 and also the next value of 6. This will have the previous value of 4, the next value of 8. So in this way it's presented. Here also we can insert at the beginning, insert at the end, insert at a specific location, we can delete, we can at the beginning, we can delete at the end, we can delete at any given data, we can search, we can traverse, we can move through them in this place. So this code is also available. So it's similar to the last one only. In the initial I've defined the node over here. Now it is a doubly linked list, so obviously it will have previous and the next node. And then these are the subcodes for each of the operations that needs to be done. In the main program, you will be asked with the choices. When you give him the choice, depending upon your choice, whether it's 1, 2, 3, will go to the particular switch to particular choice. If choice is 1, then it is insertion at the beginning. If choice is 2, it is insertion at the last. Then we have written the code for insertion for all of them. Insertion at the beginning. Similarly, the last one, since I've already defined my structure, I'm presenting that. I'm making it a dynamic. I'm giving it dynamic allocation. I'm checking whether it is possible to add data or not. If the overflow condition I'm checking, if it is possible, then I will be scanning the data that I need to put, and on the next I will be putting, since I'm inserting at the inserting the first value, isn't it? I'm inserting the first data, so it will this the first data. If you add only one, if you have only one data, then that first data is basically the last data only. So hence, for the first data, your next is also null, previous is also null. You are putting the data over here. So please go through it. You will understand the code. If you face any problem, you can message me. You will find the code. Okay. Now, what is circular linked list? The circular linked list, the last node of the list contains a pointer to the first node. Now, what happened till now? Till now, my last pointer. Till now, my last pointer. The last pointer was having null. This last pointer was having null. It was having null. What if I connect this last pointer to the first node? This last node with the first node. In that case, it will become circular, isn't it? So this is how circular linked lists are made, by connecting the by putting the pointer by pointing the first node to the last node. Hence, circular linked list will have no beginning and no ending. There are no null value present. Why? Because as you can see, this is my first node. This first node is pointing to the second is pointing to the third, and the third is again pointing back to the first. So it's a circular. Now, what is an example of circular linked list? The basic example is while browsing. Suppose while browsing, you are going from one search to another search. Again, uh, when you click the backward, you will go back to the last searched page, isn't it? So in those kind of situation, the circular linked list is useful. As you can see, the last data will have the location of the first node on list. This is circular linked list. Again, over here also you can perform all other kind of operations like insertion at the beginning, deleting, and so similar to the circular singly linked list, you will also have a circular doubly linked list. They are basically the same thing, only the last data will have the last node will have the address of the first node. That's the only difference. Thank you.